This is Chapter 6, Section 2, the inverse trig functions continued. You should have already reviewed the book, done your yellow boxes, and notice that we have basically two different scenarios that are going to occur when you're doing this section. And the first scenario we're going to start now. Okay, the first scenario is when you're given the value in your of sine inverse and it's combined with the cosine. So this is number 9, and what we want to first do is look at our restrictions on sine inverse. For sine inverse, our theta has to be in between negative pi over 2 and pi over 2. In this case, it doesn't really matter because we already know that sine of theta equals, when equals root 2 over 2, that theta is pi over 4. So, we look at cosine. Since this whole thing equals pi over 4, we're now looking at cosine of pi over 4. And this equals root 2 over 2. And you just look on your chart. This is all in quadrant 1, so it was actually pretty easy. Now what if I asked you what is cosine sine inverse of negative root 2 over 2? Then you notice, according to our domain for inverse functions, that in this case this equals negative pi over 4. So you can't say this is 7 pi over 4 because we can't go on in quadrant 2 and 3 to get to quadrant 4. We only can use this part of our unit circle, and we're starting at negative and we're going up to positive. So this is negative pi over 4. Now in this case, then we have cosine of negative pi over 4, and this equals 7 pi over 4. So notice the difference between the two answers here. All right? Here's another case. We have sine, and this is not the inverse now. So since this is not an inverse, we can use our domain as negative infinity to infinity. So negative 7 pi over 6 for number 23 would be 1/2. So this equals 1/2. And now we want sine inverse of 1/2. Now we have to do our restrictions because we're dealing with the inverse, which is negative pi over 2 to pi over 2. And when you look on your chart for 23, this would be theta. You set this to theta. Theta equals pi over 6. And that is your answer. Another scenario that you're going to have, this is pencil problem 27. Forgot to write that down. In this case, we're going to let theta, we're going to deal with this part, so we're going to let theta equal tan of 1/2, because we're just going to deal with this first. So, no, sorry. Let's look at this again. We have tan inverse of 1/2 equals theta. So we have 1/2 equals tan of theta. We know tan of theta equals y over x. So we know my y is 1, my x is 2. I need secant now. So secant, we know, equals 1 over x. Since it's r over x. I don't have my r, so I'm going to have to use the Pythagorean theorem to find r. We have 1 squared plus 2 squared equals r squared. So 5 equals r squared. So r equals root 5. How come I didn't do plus and minus? Because r is always positive. So r is root 5. X is 2. So that's my answer. This is the different scenario that you're going to get. This is when you're dealing with proportions and ratios. Let's try another one. Let's try 25. We have seek sine of theta equals 1/3. And we know sine is y over r. We know that r is 3 and y is 1. But we don't have our x. And we know tan of theta equals y over x. So we have the y part, we just don't have the x part. To find x, we're going to use the Pythagorean theorem. X squared plus y squared equals r squared. X squared plus 1 equals 9. X squared equals 8. So x equals plus or minus 2 root 2. Now, are we looking at the plus or minus? Usually when it's plus, go ahead and take the plus on it. Since we're dealing with, which problem is this, 25? We're going to go ahead and notice that theta is in quadrant 1. So we're going to take the plus. We get y is 1, x is 2 root 2. We rationalize the denominator, and we get root 2 over 4. And that is your answer. Okay? So this was right here, this was 2 root 2, because we're in theta's in quadrant 1. Okay, and these you need to know your definitions for cosecant, secant, and cotan. So make sure you know those. And we have on 39, we know that since we're doing the inverse, we have a restriction, which means that's in between negative pi over 2. Theta's in between negative pi over 2 and pi over 2. So we're seeking cosecant of theta equals -1, and that means theta equals negative pi over 2. You're not going to call this, if you say 3 pi over 2, you're incorrect. Okay, you have to go again in this area here only, from negative pi over 2 to pi over 2. You cannot go around here to get to 3 pi over 2, because we don't even have that. This has all been restricted. So this is all restricted in this area, and you can only go from here to here. Okay. Okay, so here's another one. We have cotan of theta equals negative root 3 over 2. Since we're dealing with the inverse, we need to know what our restrictions are. And we know our restrictions are in between 0 and pi. Okay, so when you look on your chart, you notice that theta would equal 2 pi over 3, because cotan of, oh, we're starting the wrong one. I did the wrong, because cotan of 2 pi over 3 equals negative root 3 over 3.